Hello students, welcome all to the introductory session on engineering mechanics. All of you are familiar with the concept of mechanics, which is a branch of science dealing with bodies at rest and bodies in motion. So from your school days you would have studied your fundamental science courses where you would have studied about the equilibrium conditions. What are the bodies at rest? What do you mean by a particle? How the particle behaves when it is subjected to various forces and things like that. This course is a very fundamental course to most of the first year students of engineering program. In this particular course, if I just go through the overview, you will be exposed to the fundamentals of statics, fundamentals of dynamics. Okay, if you look at the slide just now on the screen, you can see some of the important structures that is being used in various practical applications. You have a steering, you have a power transmission drive, you have a truss which is carrying various forces when vehicles move on it, crossing a bridge kind of structure, okay, from one bank to another bank. Recently, you could have seen a Chenab bridge, a big gigantic bridge built in our nation. We have various truss members subjected to tension forces, where it is subjected to pulling nature, and you have a compression member where there is a forces acting in the compressive fashion. And you can see some of the forces acting on certain structures like a bracket where forces are inclined, vertically upwards, horizontal forces, and various nature of forces you can observe in our day-to-day life also. Okay, various structures, various members you would have seen, observed how these particular forces are going to act on these structures and its effect on the performance of the structures and various machine members. Very important. You guys have to observe keenly in your day-to-day life the various structures, machine members subjected to different kinds of forces. In this particular course, we will not bring materials into picture. We'll be mainly focusing on the structure kind of bodies and particle, not the shapes or the materials. This course is purely focused on the bodies. We'll consider the body as a whole. We will not name it as either kind of a bearing or a shaft or a vehicle or a aircraft, things like that. We will just consider that as a body and will not bring any material into perspective, like the bodies are made of one or the other materials. Okay, if you look around you, you could have seen books, you could have seen laptops strewn on the table, pen, papers, mobile phones, plastic items, electric switchboards and things like that. We have a lot of materials. Materials also have an ability to withstand various forces based on its inherent characteristics. So that is a different ball game altogether. So we are more focused on the forces acting on the structure or members and its effects on it, how to evaluate the forces, okay, on these acting on these members, right? So we'll move forward. So just this particular slide tells you about the different branches of mechanics, like the mechanics of solids, mechanics of fluids. In detail, we'll be learning about mechanics of fluids in your higher engineering programs. So where you will be studying about the interaction of fluids, the flow of fluids, the velocity, the pressure built in the fluids in different applications. So let us not discuss those applications right now. We'll be more focused on the fundamentals of engine mechanics, where we will be considering objects in the form of solid form. So we have mechanics which deals with particles with the state of rest or in motion. If you look around you, okay, you can see various bodies in motion. Okay, so it can be the atomic level motions you can see in most of the bodies, okay, where the atoms starts agitating. It's all the fundamental unit of the matter, okay. To go for nanoparticles, microparticles, you can see a lot of things being in agitative mode. You can see vehicles moving, crossing the bridges, train, aircrafts, so many things will be in motion. Fan in your home, Okay, running around in summer season or in a comfort conditions, air conditioning systems, motors, so electrical appliances. You can see various kinds of particular components subjected to different kinds of um, motion and forces, especially dealing with solids. So mechanics is also further classified as mechanics of rigid bodies dealing with bodies at rest and bodies in motion, which we consider it as dynamics. Now, if you look into the broad classification just now from the previous slide, we discussed about solids and fluids. Let us not discuss about the fluids now. You have a solids. What are the mechanics of solids? We have a broad classification. We'll be discussing mechanics of rigid bodies. Most of the components in this world are acting as rigid bodies for ease of doing calculations, and majority of the applications of the mechanics also deals with deformable bodies, where under the action of forces the body is getting deformed or losing its shapes. In real-time applications, most of the understanding of mechanics will hover around deformable body mechanics, which we'll be learning in the case of strength of materials in the subsequent semesters of your engineering program. And in this particular course, we'll be dealing with statics and dynamics, that is called mechanics of rigid bodies. Further, mechanics of deformable bodies, you will be discussing on elasticity applications and plasticity applications, which will be a different understanding altogether as we move forward. Dynamics is further subdivided into kinematics and kinetics, playing a very important role in understanding various motions in different applications, namely robots, okay, design of robots and various machineries and mechanisms. So in mechanics, we have few idealizations to be followed. Body is considered to be rigid. We will not consider it as deformable body. Material is homogeneous and isotropic. Size of the body should be considered as small as possible when you consider it as a particle with respect to the space that is in the coordinate geometrical space. If the area over which the force is acting is too small, then the force can be treated as a point force or point loads, concentrated forces, okay, things like that. Support conditions are also idealized. What type of support the particular structure is subjected to, either it's a simply support or a fixed support and things like that. So fundamental to this particular course, all of you should be aware of the units and measurement systems followed, because engineers should be well versed with units and measurements, converting one form of units to other. So even though we follow system international units, many countries have their own way of expressing units for a typical physical phenomenon, physical quantities, things like that. So we all are familiar with this slide. Okay, we have various high magnification numbers depicted in terms of mega and giga and kilo form, and lower sub multiples in the form of milli, centi, and micro, nano, angstroms, like that. So you can see the symbolic representation of milli, micron. Don't confuse with milli. Milli is meter, but we'll define it as 10 power minus 3. Microns in myoM, nano in N, or you can also write nanometers. Okay, gigawatt, megawatt, kilowatt, small k followed by capital W is kilowatt. You would have familiar with the applications in various power generation systems. We'll define the capacity of the various turbines and generators in terms of kilowatt, megawatt, gigawatt, things like that, high range of quantities. Whereas in terms of nanoparticles, we use 10 power minus 9, minus 8, 100 nanometers, 10 nanometers, 1 nanometer, like that. Or in terms of microns, where you will seeing in the microstructure of materials, very small entities will be defining in microns, micrometer. So fundamental units are the primary and derived units. All of you know this: mass, length, time. They are the fundamental units, very much used, denoted by kilogram, meter, and second as their unit, and symbolically it is represented by kg, mass, M for meter and S per second. All of you are familiar with it. And force is a fundamental to the learning of engineering mechanics defined by Newton. We'll discuss that the scalar and vector quantities in the subsequent slide. From Newton's second law, you're familiar with F equals ma, mass into acceleration, and the force unit of force is Newton, and the acceleration is meter per second square, and the product of the mass kg and acceleration, which is the rate of change of velocity. Rate of change of velocity, that is meter per second square. Okay, Newton is the force required to give a mass of 1 kg by an acceleration which moves by an acceleration of 1 meters per second square. It's a fundamental unit of force, and weight is also depicted in terms of newtons, which is a kind of force which acts vertically downwards on planet Earth or any other planet, which is the g is the acceleration due to gravity. You can see a system of forces acting on a particle or a body, whatever it is. This, you can see the round object here. Okay, so these forces are acting in different fashion. Okay, in the inclined fashion, vertical fashion. If you want to consider to be in equilibrium all the forces acting on the body, the resultant will be considered as zero. The net effect is zero. Okay, we call such as equilibrium condition. All of you are familiar with first law. Particle originally at rest or even moving in a straight line with constant velocity tends to remain in that state until you disturb that particular activity by an unbalanced forces. Okay, first law contains the principle of equilibrium of forces. Mainly the topic it will be concerned in statics. Second law deals with the dynamics aspect. Here you can see a mass acted upon by an unbalanced force F experiences an acceleration A, right? You can have a look into this. And acceleration A, same direction of the force and magnitude, that is directly proportional to the force. F equals ma, a famous equation you would have studied in your school physics. So this particular law is also very important in engineering applications, which is being used to build various types of machines and vehicles. Third law deals with the action-reaction phenomenon. Okay, so for every action there will be an equal and opposite reaction, and the collinear action. Okay, so this is very, very important in most of the engineering field. The fundamental law that governs the behavior of most of the engineering systems. So we have many engineering unit systems followed by different countries. From years, foot pound second, meter kilogram second, centimeter gram second, and system international unit, which is basically we use meter, Newton, and things like that. So engineering students should be well versed with these primary units, different units. You know, if you go to UK or kind of European nations, you can see some of the units being followed still now in the form of foot, pound, and things like that for measuring forces, weight, and things like that. They use the word pound. The distances are measured in feet. Even in our country ruled by Britishers for a long time, we still use inch, feet, foot, and things like that, yard. Okay, and MKS systems basically deals with meters, kilogram for mass, meter for length, and time in seconds. So basic units and SI units, fundamental things have been mentioned in this slide. These are the physical quantities, which are basically the primary units like meter, kilogram, second, which are familiar with. Current is denoted by ampere, temperature in Kelvin, and luminous intensity is candela. If not, we'll not be much focused on this luminous intensity applications right now. So acceleration, angular velocity, angular acceleration, these are called derived units. Work, energy, torque, power, fundamental to engineering applications. So all of you are familiar with these units. You should be well versed with pascals for unit as pressure, Newton per meter square, watt joules per second. You to practice these units, fundamental units. You should be remembering this as quick and practice this. So you should be writing these units at your fingertips when they're mentioned under different problems. Scalar quantity is one which has only magnitude but no direction. So some of the physical quantities which fall in the category of scalar is the mass, length, time and temperature. They don't have directions. We'll only define it by a magnitude. Okay, like 100 degrees Celsius temperature, eastwards, westwards, no, 100 degrees Celsius temperature or 250 degrees Celsius temperature or elevated temperature, sub-zero temperature, time of the day, okay, length of an object, mass of the particle, things like that. Vector quantity has both magnitude and direction. Fundamental vector quantity is force, which is widely used in the study of mechanics, whether it is rigid body or deformable body mechanics. Momentum, velocity, acceleration are the terms which will be used in understanding dynamics, kinetics and kinematics of various machineries, which you will be learning in your course of your engineering. So force is an agent capable of changing body's state of rest or in motion. Whenever you see multiple forces acting on an object like a crane hook or any hook which is holding various members, okay, you can see we call such systems as force system. Okay, you can see a bracket being pulled at certain force of P newtons, inclined at an angle theta. There are various cables being used. The person is rotating a spanner, applying a force F from a distance D at the axis of that particular rod. Okay, so we call this as a moment, twisting moment or torque, things like that. We have different force system, coplanar systems, non-coplanar system, where forces are acting on a common plane, where forces are not acting on a single plane. If it is on coplanar, we have collinear, concurrent, parallel and non-concurrent, non-parallel systems. If it is non-coplanar also, you will have see collinear, concurrent, parallel, non-concurrent and non-parallel systems. But you will be seeing in different planes. You can see collinear forces, 3 kids pulling a rope, kind of coplanar forces, coplanar like parallel, coplanar concurrent. You can see the forces are meeting at a point or originating from a point, diverting itself from a point in a single plane. We call it as coplanar concurrent force. Non-coplanar parallel, non-coplanar concurrent, non-coplanar non-concurrent, varieties of forces you will see. You can see a coplanar concurrent forces on an inclined plane, a wedge application or a truss applications on this slide. There are 3 laws of statics which is widely used. That is the algebraic sum of horizontal forces as 0, algebraic sum of all the vertical forces as 0. And the moment about a point O is equal to 0. These laws are fundamental to solving problems on statics, which are called the 3 laws of statics. Okay, and we'll use some sign convention and we'll try to understand these things better in the days to come as we move forward in the journey of learning engineering mechanics fundamentals. Thank you guys.